here's our basic introduction to virtualization. If somebody asks what virtualization is, it's rather hard to say it means this, it means that. It's a term that's largely been brought up by salespeople, a bit of a buzzword to mean certain things. So a company might require virtualization to mean one thing or mean another. It's encompassing a number of technologies that existed for a while, and they put the buzzword virtualization behind it. So a number of things can be said, this is virtualization. And they do run along the same basic pattern, the same idea, but they aren't always exactly the same thing. We're going to cover all those things in our course, all the different levels and so forth. Here's our issue with what we've got. At our simplest, we have a computer. And on the computer is some stuff. Whatever. And one of the most important things is an operating system. And the operating system allows us to do things. It can interact with the hardware. It can take messages, prioritize things, maybe allow us to enter data and push things back out again if we're lucky. That's great. At its simplest, in a fairly modern computer, we have a hard disk, and on the hard disk runs an operating system. Runs Windows, runs Linux, runs OS X, or whatever. That's it, end of show. We can take that a bit further. Inside our computer, when it first boots up, we get the basic BIOS, tiny operating system, embedded inside the machine. One of the first tasks it makes as it boots up decides, what am I going to pass on to? BIOS doesn't do an awful lot. It can see things, it can turn on, it can find simple programs. One thing is, let's work out what I'm going to boot first. So you've got a boot order. It might boot from the hard drive. We could boot it from the CD-ROM or the USB disk, or an old duck machine from the floppy drive. Go on, it wouldn't do that much. So instead we might boot into the USB drive. We might boot an OS from the USB stick. Do that. We might boot a USB hard drive. We might boot from a CD-ROM, so we can put a live CD, quite a common thing. Download your live CD, burn as ISO, pop in CD-ROM drive, DVD-ROM drive, spins up, you've got an OS straight away. We run the same OS from a machine without changing the install. We're away like this, but only one at any one time. So I can run it with Windows in the main box. I could run something called Slacks or a USB Ubuntu from a pen drive. I could run live Fedora from a USB, from a CD-ROM drive. Great, but only got one. As soon as it boots up into Ubuntu, we've lost Windows. We can read the Windows disks up to a point. We can't actually run the Windows operating system. Bit of a bummer. Okay, how can I overcome that? One way is I can emulate things. So I can emulate one operating system from another. One of the most common ones, it doesn't work very well, but it's common enough, is Wine, the Windows operator under Unix. So I'll have a Linux box and run Wine, and inside Wine I can sometimes run Windows programs. It runs Notepad like a dream. Everything else, maybe, maybe not. See how it goes. The more graphics, the less chance of doing it. And that's one way. I'm okay, I'm done like this. I could run two things at the same time. But if it's not compatible with the emulator, it's all sad, not going to happen, end of story. The next step up is, alright, I can have a virtual machine. I can run a program inside an existing operating system, and that program runs another operating system. This is the crux that we're going to play with. So we run a program in Windows, or OS X, or Linux, and that program is a program that can run an operating system. Fairly straightforward. So somewhere we've got, here's my Windows machine, or my Linux, or whatever, and there might be inside it somewhere a window, and inside that window this might be running Linux, and that might be running Windows. We could have several of these for the time we keep it simple. So that's a virtual machine. This machine is inside that one. My machine runs Windows, but it also virtually runs Linux. We cannot take the Linux machine and physically cart it somewhere and move it. We can virtually move it. I'll come back to that. So this is a good place to start thinking about things. It does offer certain capacities that we might not otherwise get. For example, if I need to run a Linux sort of thing, I've got a Windows box, we'll put the Linux things in the Linux virtual machine, run the Windows box, and we're good to go. So we could run a Linux LAMP server in here, serving our web pages, and we could run some Microsoft only thing over here, access perhaps on this one. Now, The LAMP server isn't going to talk to Access in a hurry, I'll tell you that. But the two could run separately, be happy enough like this, and we're away. There are a number of issues where this is quite handy to work it out there. From a lesson learning point of view, you, rather than needing to install several machines, okay, today we're going to turn on the Windows machine, tomorrow we'll turn on the Ubuntu machine, next day the OS X machine. You could have a virtual machine for Linux, for OS X, for Fedora, whatever you want up there. Now, if you turn on your virtual machine, you're going to boot the Linux one today, tomorrow you might boot the Fedora one, the next day you might boot some other some other distribution or whatever. So you can do all your work without a new machine each time. Some institutions will provide the virtual image. So we could set up a student virtual image and have all the stuff we've done there for the students, give you the virtual image, subject to licensing agreements, and then you could put that on another machine and move it round. So your virtual image, your accounts, your programs can move with you from one place to the other. It's not magic, it's not super powerful. If your machine is completely hardware incompatible with the other image, then it's probably not going to work. But it's not too bad, it has a pretty good go at it, so it's handy for learning like that. Also consider the fact that if I've got an awful lot of different machines, I can put what I need on the virtual image. So I can have a server somewhere, and my server is going to have a web server, an Active Directory server, an LDAP server, or whatever. Yeah? And rather than lots of different servers for all these boxes, I buy one or two top-of-the-range boxes, stacks of RAM, stacks of hard disk spaces, best hot swappable hard disk, the whole bells and whistles. Put all the money on one decent machine rather than 6 middling machines. Pop it on one good machine, and have lots of virtual machines running on that, they all run on the same thing. At its best, I can move that. So let's say that today I have a virtual solution with virtual LDAP, virtual LAMP, or whatever on different virtual images. And in 4 years' time, that machine's getting a bit laggity, getting a bit crotchety, a bit past its best. So I buy another machine, similar but better, and take that virtual machine from my old machine to my new virtual machine, another virtual image, and it appears that I haven't done anything. You as the user, out on the network somewhere, still log on, still see the web pages. But I've moved all stuff seamlessly from machine A to machine B, because I've moved the virtual machine from physical machine A to physical machine B. Physical machine A is done, dimp it, gone, and move on to machine B. That's a tidy way like that. What else can we do? We can reduce maintenance and hardware costs. So if I've got 10 machines all getting a bit older, then I've got 10 to sort out, 10 to go and drive to or find or whatever. I've only got one machine, it's the best kit I can afford. Hopefully I've got hot pluggable hard drives and stuff like this, and I can just change it over straight away. So I put all my money in 1 or 2 boxes rather than lots of them. So it might be best, but big on virtual machines, but a backup machine in case the worst comes to the worst. Is a tiny, well, big really, security issue. If these are just files, anybody can take those files. So if you've got a virtual machine, and your virtual machine is all your account servers for all your customers, it's all their credit card details, somebody could actually take that image, or even clone that image. So they'll take an image of your virtual machine, got all the customer stuff on it there, and they're gone. And you don't know, because your physical machine's still sat there, still blinking away, flashing lights, cables, no problem. It doesn't know a copy's been taken, they've got the copy and they're away. In theory, a suitable password system and encryption and so on should fix that issue, but it is a possible issue. If you've got a real machine, somebody steals your real server, then you can tell by the gaping hole in the plugs going out the wall that something's happened. If they stole your virtual machine, then it's stolen a copy of a virtual machine, unless they're really stupid, delete it. They've stolen a copy of a virtual machine, they've got that copy, got your accounts, got your sales, or whatever, so you don't even know they've got it. But that's security. You've got networks with security issues. So, there's a communication problem between them. There's not a problem, an issue, shall we say. Let's say what's going on the web, as you do. This machine can access the web, and if it's set up right, so can this machine. But because of the way it runs inside its little sandbox, unless we actually change some settings to get data from this machine to that machine, not impossible, it's achievable, but it's not straightforward. They're locked down. So if you've got access to the Windows host machine, want to put some files on the Linux guest or virtual machine, you can't just go into Linux, browse the Windows drives, drag them across, and you're good to go. There are ways we can get around it. We can go out onto the network and back in again, or we can allow certain services to pass between the pair of them. But by default, set up, you can't move files from one another. One of the easiest ways for a quick fix is generally your virtual machine has access to certain things the host has got. Obviously, keyboard and mouse, otherwise you need a separate keyboard and mouse, and that's bonkers stupid. Or a virtual keyboard, again, don't even go there. So a virtual machine can read from the mouse and the keyboard. It can almost certainly read from the USB drive, and it will definitely write from the CD-ROM drive. So, we want to transfer some stuff, burn to CD-ROM, put in CD-ROM drive, virtual machine reads CD-ROM drive, and get it that way. If we're lucky, it can mount the USB drive. There are more efficient ways of doing this, but we can move between. Just be aware it's a bit of an issue. So that's our basic step one. We've got a virtual machine, or several virtual machines, running on one host, allowing us access to different operating systems at the same time without having to shut the machine down. We'll move on a tiny bit. Is what we've got here is virtual machines. And as I mentioned, it could be an education institution somewhere, and they set up a virtual machine, which is your drive, and then if you wanted to take it home, you could take home a burnt copy, a DVD-ROM perhaps, of your virtual machine, put it inside your own host machine, and maybe, with luck and the following wind, it'll boot up and you're good to go. Well, thinking it through, do we really need to put it on a DVD and move it from A to B? Heck no, we don't. We've got our networking goodness to play with. So, if we're allowing people to access or use this virtual machine from somewhere else,